Welcome back, everybody. Today's gonna be fun because I'm gonna be showing you guys how to do a fixture map on this Subaru subframe right here. Now, this is a YouTuber that has a dragon wagon and minimal tooling, so it's been requested that we do a fixture map and help him hold this engine cradle with the minimal amount of tooling as possible. So unfortunately, I don't have any real dimensions or what's critical. I don't know if these slots are critical, but what I can tell you is we're gonna try to hold these parts as close as possible in this 3D model and try to create some fixturing for it. Okay, so what I notice is when we import this in and we just kind of look at it, the first thing you're going to do is go, wow, what the heck is this? There's some weird geometry. If we look at it from the side, some angles over here, nothing's really flat. If we look at the way the brackets are, these things hang over the edge. This is not going to be an easy little thing, even though it looks simple, and the tab and slots kind of lock everything together in theory. So if you've never worked with tab and slots before, they're just an interlocking joint laser cut. Now they are pretty accurate, but there is quite a bit of movement in them still, which means when they interlock with each other, they can still flex and move. They do lock distances, but they don't really keep the wobble out of them. And I really like using them, but they can get you in trouble also. So what we're going to do is we're going to base all our fixturing off of their desired measurements. And then if something's wrong with their bends, so that's the other thing too, is you look at these are all bent. So what I'm assuming is happening is these are flat cut lasered and then they're bent afterwards. And if those bends aren't perfectly in the right spot or the bend radius isn't bend correct, those slots now move. So you can see how, as if you were to just use those after they were bent incorrectly, that the dimensions are going to change. So I would like to set up fixtures that are going to help identify if the lengths on all of these are correct. So they're great, but let's make sure we get them situated. So when I look at this, I'm kind of biased to separating components into sub-assemblies. So I'm going to bring in my table here and I'm going to show you why. Okay, I'm going to flip this over and I'm going to mate this surface to the top of the table because I think this is what will actually touch. And then let's make this line parallel with this line. So now we can kind of see what we're looking at here. And just for this exercise, I'm going to change the color a little easier to see. So if this is sitting down on the table, this back piece is pretty straightforward, right? There's no bends in it. There's nothing. This part's going to be easy to lock down. So I'm not too worried about this piece. But this piece in the front is the one that's going to probably give somebody some problems. All right, so what I'd like to do is take these parts and I'd like to suppress them and just work on this front piece. So all I got to do is find the parts that I'd like to suppress, like this one, engine cradle, and I'm just going to come up here to suppress. Okay, so we're back to this. Now I need to focus on this goofy thing. I do know if we get rid of these ears, that will simplify things a little bit too. So let's find the little ears. Okay, so now we're just left with this guy. Okay, we're going to flip it over, swing it around. See, 0.25, quarter inch off the deck. See, do we get some clearance there? Can we see? Yep. Okay, so we got clearance there. That's a quarter inch shim. Okay, so now we need to worry about where does this go. So I always like to start with something easy, like a fence block. Let's locate endo right here with a fence block. So we're going to insert components, and I'm going to grab a fence block. We're going to locate this endo, but I want to make sure I'm kind of in front of this first. Locate that. I'm going to mate. Let's talk about this. Do we put the block here on the front of this bend, or do we put the block on the back where this is laser cut? I don't trust the bend to be in the correct location. Let's not use that. Let's scoot this down just a little bit here. Like I said, a lot of this is just eyeball. One there. Let's put one here. I'm going to select all these blocks just like that. Okay, now let's mate this surface because this is a laser cut edge with this laser cut, or that part right there. Okay, liking this. So we're gonna move left or right. So that's what we're kind of trying to locate, right? So let's put another fence block in here. We're trying to build redundant systems that help us identify problems. Okay, so this goes there. Yep, this goes here. Now we touch this piece to the fence block. Boom. Now we need this side over here. but it doesn't look like it's the correct measurement. So let's see what it is. So let's evaluate just for fun. We want this block to this surface, and that is 35 inches, 62 thousandths. So about 35 and a 16th. Okay, so what I'm going to do is I'm going to use a tooth block to set that. All right, so I pulled in my tooth block. This one's got a riser on it. We don't really need it for this application, but I'm going to leave it on there. Okay, we're going to mate this guy to the floor. And then we're going to grab him over here, get him all squared up. Yep. And then I'm just going to touch him. So we've taken care of that. Trying to do it with as little fixtures as possible. We need to set this angle. But technically the angle's already been set. You kind of see where we're going with this? This cannot move. So we need to set this distance right here. Can we? Let's look at the slot here. They have this married into that slot. It's gonna bottom out, but what happens if this slot is incorrect? So here's what we'll do. I think we should put another block here. Let's grab another tooth block. To grab another one, you just have to hit Control and drag it. So where do we want him? Do we get a pick? See, this is one of the reasons why I like the Fireball system. It's because our fixtures are 2 inches wide. If this was a 5/8 system, we'd kind of be barely on the roll right here. So we get to pick this hole or this hole. I think we're going to pick this one. But our blocks are wide, so we technically have full coverage across here, where some of the Buildpro and other 16mm tooling, they're a little narrow. Now, if you look at the tooth block, we got to make sure that the hole's going forward. Okay, so now we have a dead-headed corner where that goes into. We know that it's got to lock into this piece at this location. So let's add one more over here. I'm just going to mirror it over. I promise you, it's going to get easier after this little piece is done. This is the hardest piece to do. And I think this is the one that's giving them the most trouble. Now, we could add one more for safety, which means is this slot right here in this piece. What I mean by that is this slot could be incorrect with the way they bent. We're talking a few thousandths of an inch. So I'm going to add another block right here. So what this is going to do is this is going to set the angle. So let's put it right there. Okay, so now let's just take a look at what we have. I have all the fixtures and they're all on one side. So this is good, which means is after I put all my parts in, we have a gap underneath here. So obviously we're going to have a shim, a 1/4 inch shim. Then once I get this all tacked together, then I can just pull it out, put new parts in, boop, and it's all going to be in the correct spot, right? So if I was adding this piece in, I would make sure that it's touching this block, or I'm going to open up this slot. So if it doesn't touch this block over here, I'm going to come in with a skinny wheel and I'm going to open up this slot a little bit. Okay, so that way the overall dimension stays the same, because remember we're adding parts to these. So these are very critical. And then it's flat on the table because we'll put some shims in there. We can put some clamps down. What I'm thinking you could do is after you get this welded, these brackets just kind of slip into place. I don't think they're that critical. We could create another little setup to put these in the same spot. Okay, so now we have these goofy little tabs. They look very important. These little guys right here. So I'm just going to hold Control and I'm going to click. I'm going to drag us a new assembly off here. Now let's just pretend we got our 3 parts welded together. Okay. Now we have these goofy things to deal with. Sure, tricky. Now if you look at it, this tab sticks out past this part. Okay, there's lower. So we have different elevations here. So I'd like to maybe use this edge as a reference. Remember, we already have the boomerang welded. So it'd be nice to do this all in one shot, but this is gonna happen. This was designed funky, right? I mean, if this was me designing this, I would have cut this shorter so everything would have been the same plane and we could have probably built it upside down. But it is what it is. And I'm sure as these guys move forward with their project, they'll find ways to refine their system a little bit. Okay, so I'm just gonna pretend we're gonna do an op 2 on this to get these brackets in place. So if these were broke incorrectly, we want a fixture to be able to tell us that they are not the right angle. We need to set the angle to make sure it's right. We need to make sure that it's plumb 90 degrees to the table. Okay, so we need to have something that controls that, and we need to have something that controls how far out it is, right? Because we don't know if that slot is cut correctly. So we have those 3 dimensions that we're going to have to control on this face right here. Let's just grab 2 more blocks. An op2 could look like this, and you're going to reuse your fixtures from op1. And this is not uncommon. Okay, so I want this part to be centered. So a simple way to do this, we need a width mate. So I'm going to hold control that surface, that surface, that surface, and this one. Okay, 4 surfaces selected. All I have to do is come up here and hit mate. See, tab referenced, width reference. Hit OK. There we go. Okay, so now this part is centered, and this is going to be important for this next step. I'm going to grab another block right here, another tooth block. So I'm going to grab this guy, these risers. You see how they got a pin in them? We're just going to mate him up to here. We're going to add a riser. And here to here. Okay, it's at this point where we could put a shim underneath here to just kind of keep that wing from flopping around. But now we've located endo. We'll come back and grab this measurement later. But now we're centered. So now whatever I do to this one, I can repeat on this side and it's going to be the same. So what I'm thinking is that we grab another block. I don't know if it's going to work. Let's just try this. I have an idea. Okay, let's talk about something. Put the block right here. Mate that surface just like that. Do it, do it, do it. Boom, Jason, you did it. You're the best. That was so easy. But here is the dilemma. I don't know where this goes. I can go distant, right? But I don't know where to swivel it. I'd have to pull out a protractor. I have this beautiful grid of all these holes giving me exact layouts, and I'm gonna pull out a protractor to set this. Protractor and measure off of what? This? Put another block in here and measure it off of? That's all fine and dandy, right? But it's not repeatable. It works for today, but now I want to give this project to somebody else. Maybe or come back to it in the future. And you have to now tell them the angle. There's no way to tell them where to put this block exactly. So we're gonna give ourselves this dimension. So let's peel off another one of these guys and we're gonna tell it where to go, which means that any other time and date, we can come back and put this in. So I'm gonna put this block here. So right now, I'm gonna mate this piece to this piece. Now with this part pinned, I know the distance. The angle is set by this block right here, which is locked in, and we know its distance. So now we can create a fixture map and go put that fixture right there, and then swing this block over until it touches, and then set this distance, boom. Now we have in, out, angle, distance, vertical. It's gonna hold it plumb, and the whole 9. Well, this is a really unorthodox way to do it, but it does work, and it's accurate without any other tools. So we could go down on the shop floor right now and set this up, and I wouldn't have to pull a protractor out. How cool is that, right? This is so cool because I could pass this project off with just about anybody, and I know they could complete it. We just mate all the corners up. There you go. So there's 2 setups. That's gonna tell you everything you need. You could pull measurements across here with a tape measure just to make sure you're kind of square before you tack anything. And then off you go. You could put some clamps down onto it because remember, this is already fabbed up. Okay, now that this is all done, let's do op 3. I'm gonna pull off another table. So we would strip that all down. All our parts would be made. I'm just gonna mate this table up to this one. Okay, once again, we got all this mumbo jumbo to deal with. What I wanna do is I'm gonna mate him down to the table, because this is what we're dealing with now. And we're gonna hang him over the edge like this. Let's make this back line parallel. This edge and this edge of the table. Okay, that's kind of squared up here. Now let's look at it. Okay, so now we could probably bump these guys into that table maybe. We're gonna set the backstop, treat this as just a normal box frame. And then this part will just clunk in there. We have laser cut parts here. So let's reference off the inside, not the outside. Let's grab another one. Just gonna make this fast. So we got a weld on this inside corner, I'm assuming, so we don't want to go too far in there and block everything. Now we got a nice laser cut edge we're gonna reference off of here. Not the stupid bend line. Don't make assumptions that the bends are correct. That's looking pretty snazzy, so let's just add ourselves another fence block over here. So once again, I like to go perpendicular with the blocks. You most certainly can go lengthwise if you wanted to. Let's move him as close as we can to the edge of the table. And we'll move him close to the edge of the table. So now we will mate this bar up to him. Excellent. We're gonna grab him here. Give ourselves a little wiggle room. One more. Make it fast. You always try to want to put your blocks as far away as possible. Ta-da! So we just built that frame out, and this part is all fabricated, all welded out, ready to go, and it just drops in. Clunk. This would all be fixtured, and if there was a problem with warping, maybe this warped a little bit, this setup right here is going to tell us. It's going to tell us that we've stretched it or shrunk. So we're going to have to maybe heat it up, bend it back, or cut a groove back in here so that it locks in place. But it's going to identify that there was a problem during fabrication. So these are all redundant systems, especially since this is an engine cradle. When it goes in the car, it has to fit. So now let's create a fixture map of all this mumbo jumbo. Now I just got to put the block in the correct hole. So a good example of this thing is this hole right here. The tooth block is B13. Bingo, you sunk my battleship, right? But the ones we're worried about is the ones like these. So tooth blocks, we want to know how far they're extended. Here, I like to go here. We need to figure out where the center line of these holes are. So you come up to the eye, select this icon right here as the center line mark, and then I come up to sketch and I grab this point, and we're trying to get this radius to the first hole on the table. So remember, this is the slot on the tooth block. How far has it shifted off of the table hole? That dimension is what we're after. How far forward has this block moved? We need to know that number. Like this one, see how this is the table hole there? That is too far forward. So, but this is the edge of the radius to this next hole back. What is that number? And then once we know that number, we can accurately place them on the table. Now I grab my smart dimension and I just come through here and hit how far has it extended. 7/16. Awesome. Grab this next one, 3/4. This one, 1 5/8. Yep, we're just gonna go around the room. 1/8 of an inch, 11/16. Oh, so that's, be careful with this. See how it's at an angle? We don't want that. We want it like that. How far has it extended linearly? And what we're looking for is anything kind of weird. Like if we see something mirrored, these parts are mirrored and we get unequal values, well, we need to figure out why. Over to this side, just like that. We got all our maps. So like I said, you wouldn't necessarily need to have all of these set up. We can repurpose a lot of them after you're done with op 1, then you can move some of these over to op 2, then op 2 to over to op 3. So everybody should have at least, I'd say at least 8 tooth blocks and 12 fence blocks so in your kit, so they could easily fixture this with simple stuff. And I know you're probably saying, Jason, what is the actual measurement? What is the angle to the dangle of this block? Let's check that. Sorry, 68 degrees is that angle. Let's go downstairs and set this up and see what it looks like. Okay, see you down there. All right, we have our fixture map done, ready to go, and we have our dragon wagon here. Remember, this is a 54 by 30, and we're building on this table because this is the table he has. Would we be better off to build on a bigger table? Absolutely. And there's always gonna be a project that's too big for your table. That's just the way it works. No matter if you have a big one or a small one, you're always gonna need a larger. So just remember, you can break up your part into sub-assemblies, and that's really helpful. Okay, so now all that said and done, I want to show you how quickly we can set up the fixtures. So I'm going to start with op 1, and we're going to use this side of the table to set the fixtures up with. All right, so all I'm going to do is just follow the map, right? Everything that we've already laid out, set all the fixtures in place. So I always like to start with the fence blocks because they're the easiest, and it kind of just sets everything up. It should only take a few seconds. 13L. And if you notice, the table is all labeled already for me, so I just follow the grid like a game of Battleship. 13L. 1 2 3 4. 1 2 3 4. Okay, we're almost done already. Okay, 24. All right, now I have 1 2 3 4 5 tooth blocks. It consists of 2 parts. One is a base washer with teeth in it that corresponds with teeth on the bottom of the slide. What happens here is the washer goes down into the location that we've set up by the map. The top goes over the top and indicates it. So this one's got a riser on it. I'm just gonna leave it on there. It's not gonna hurt anything. Okay, and I'm gonna grab my tooth washers
Looks like I need 4 1/8 inchers. What I mean is these are the tooth washers and they're 1/8 inch. So it sets this block on every 1/8 inch increment and 1 on a 16th. Why do we have 2 separate ones? When this washer is underneath the tooth block, you know that it's a 16th. It cannot be anything other than that. And it's a simple visual check and you know you're gonna be right on. Believe me, if you get one of these wrong, it could throw off their whole system. So we've devised a way just to keep it separate and not mess anything up. Okay, so I just like to get some pins out. I need 5 of those locking pins and 5 of these swivel pins. So this is the Dragon Wagon. When using the Dragon Wagon, you need these little red collars. And what that does is it makes this bolt shorter, okay? Because this table is a 1/2 inch thick. The big tables we use are 1 inch thick, so we need to take up that distance. We do that so that you don't have to buy a whole bunch of different length bolts. And if you ever decide to get a bigger table later, all your fixtures are exactly the same. Now that I got everything out on the table, I'm ready to set everything up. And I'm just gonna start left to right. We'll just put him over here. Washer 19J. And we are extended 1 5/8. Almost done here, 3 more. And all I'm doing is following the map. As you can see, I'm just bringing this out to 3/4 inch, and extending it and dropping it into place. It's really that easy. Last one, 5K, and we're at 7/16. Okay, done. So that would be op 1. So what I like about this system is that I can set this fixture map up for somebody that's not even here, and they can set it up exactly the way I do. This is a repeatable setup. All right, so here's the scenario. We have our fixture set up. If I had 50 of these engine mounts to do, I would make all 50 parts, set them all off to the side with op number 1. If I have enough fixtures to set up op number 2, I could do that right now and leave these in place. Okay, op number 2, I'm gonna repurpose all my parts. So I'm gonna take these all down. And remember, op 1 is already done, already welded out. So let's see how long that takes me. And just like before, just following the map is actually pretty boring. I don't have to follow any order. There's no process. As long as I just go from left to right, putting the fixtures where they belong. We've already done all the hard work in CAD. Or now this is the tricky part, the angle, right? Remember we had to set that angle up? So I'm just gonna follow the map again. That's where this component comes into play. So I'm in hole E12. So remember on our map, we're extended out 3/4 inch. Right, see, I'm gonna extend it out 3/4 inch to get this angle. And there you go, I bumped it into that stop. I'm gonna lock it down. Now this block prevents this from rotating. It's set. We'll check that here in a second. And we're just gonna mirror the same thing on this side. So the great thing about a fixture table is that we're mirrored. Okay, they're set up number 2. Let's do a fun little angle check. Let's see if we're right. This is supposed to be a 68-degree angle, exactly 68 degrees. So we set this fixture up at the exact angle we want and at the exact distance we wanted with no tape measure. Like, this is what I've been waiting for my entire career, is something like this. There you go. And exactly for this other side. Now, if we were off 0.1, 0.2, 0.3 off of this, I think that'd be more than acceptable. But isn't that fabulous? That is just incredible. All right, so there's op 2. That was pretty quick. That only took 2 or 3 minutes to do that. And we used all the same fixtures. Okay, now op 2 fixture is done. Now use your imagination. Remember, we have a pile of parts sitting over here to the side of the table that we're gonna run through this operation. And when I'm done with those, I'm gonna take these down and then we're gonna switch to op 3, which we're gonna do right now. Op 3 is done. Take all my components that I just built, put them in op 3, weld them together for the final time. That's how I'd set that up. Okay, so we did it. We took a 3D CAD model and we turned it into a fixture map. That is so cool. And I would love to do more of that for you guys. Taking your ideas that are out in space in the computer world and then turning them into reality right here at the Fireball table. Because the Fireball table is so easy and so simple to set up, it's teachable, and that's what I like to do. So what I want to do is teach more of this, but I want to use your guys' real content, your real projects that need solutions. And I know this fixture map is still kind of new, so I want to continue to help you. So what you can do for me is leave your project ideas and your drawings at the Fireball Tool Forum. Make a post, give a little description of what you got and how you'd like it solved. I'm gonna take that content and make a video for you, and then present it here on the table. That way it gets you started. This is what separates Fireball from everybody else, is because we are able to do these videos and I can actually teach you how to use these tables and get maximum efficiency out of this system. So thank you guys for watching this fixture mapping video, and I'll see you on the next one.